Okay, this is podcast 3.6 for chemistry, and we're going to talk about how you name and write acids. So the first thing you need to know is what is an acid, and a very simple definition of an acid is right here. Acids produce H plus in water. So usually when you have a strong acid, it dissociates completely in water. What that means is when it goes in, so I have HCl, it splits up into its anion and cation, and that's what happened here. HCl will split apart and you'll get the H plus and the Cl minus. So when we're producing H plus, that tells us we have an acid. Bases produce hydroxide ions, and that's strong bases. And these are very simple definitions of acids and bases, but we'll talk more about them later on in the year. For our purposes, acids are only going to begin with a hydrogen, so that's how you're going to be able to tell if it's an acid if it starts with a hydrogen. And then you need to know that there's two types of acids. There's a binary acid, which is a hydrogen or hydrogens attached to a single element, and there's also polyatomic acids where the hydrogen is attached to a polyatomic anion. Now, this does not have to be just a single hydrogen. This can be more than one hydrogen. So it's important that you remember that. So it can be more than one. All right, so our naming rules for acids. You have two different sets of rules depending on whether it's a binary or a polyatomic. The binary acids, you're going to use the prefix hydro. So as soon as you see that it's a hydrogen with a single element, you're going to write the word hydro. And then to figure out the rest of it, you look up the second element's name and you change it to ic. So instead of before how we were changing it to ide, when it's an acid we use the ending ic. And then we add the word acid at the end. So our example that we had from the last slide is HCl. HCl is a hydrogen attached to a chlorine, so it's a binary. We would write the word hydro. Chlorine would become chloric, so hydro, chloric, and then we add the word acid. So you're only going to see this prefix hydro if it's a binary acid. If it's a polyatomic acid, we don't use the prefix hydro. All we do is we look up the polyatomic that's attached to the hydrogens, and we have to look at the ending of the polyatomic. If it ends in ate, it becomes ic. If it ends in ite, we change it to ous. And a saying that I use to remember this is that I ate something icky. So you can remember that ate becomes ic, and then the other one must be the ite to the ous. And then we also add the word acid. An example of one we can use is H2SO4. H2SO4, this is a polyatomic acid because I have a hydrogen or hydrogens attached to my polyatomic anion right there. That polyatomic anion is sulfate, and since it ends in ate, it's going to become ic. So this is sulfuric, and then acid. So really important that you see the difference with the prefix hydro. We do not use hydro all the time, it only is with binary acids, and then we just change the ending of the polyatomic ions when we're dealing with polyatomic acids. So we're going to try a couple on the next slide. All right, hydrosulfuric. Hydro is the key here because it tells me it must be H plus an element. So I'm not going to be using polyatomic ions. We're going to be using an element. And sulfuric is sulfur. So I have hydrogen and I'm attaching it to a sulfur. And we do need to balance charges like we do with ionic compounds. So a hydrogen is a +1, and sulfur is still a -2 like it always has been. So I need 2 of the hydrogens to balance with the sulfur. So this would be H2S. Phosphoric, since there is no hydrophosphoric, what I know is that this must be a polyatomic because they did not use the prefix hydro. So I'm going to go to that anions list, and I have to remember that if it was ic, it came from ate. So this must be phosphate. And if I find phosphate under the anions list, I'm going to see that it's PO4 and it has a 3- charge. It's an acid. It has to have hydrogen at the beginning. So hydrogen is there. It's still a +1. And if I need to balance charges, I'm going to need 3 of the hydrogens for every 1 of the phosphates. So phosphoric acid is H3PO4. This is sulfurous acid. Again, no hydro in front, so this must be a polyatomic acid. So I go to that anions list on the back of my periodic table, but this time I'm not going to be looking for sulfate, I'm going to be looking for sulfite because that OUS came from the ite ending. So this is sulfite. And sulfite, if we look it up, is SO3 and it has a 2- charge. I still need to have my hydrogens in front, and this time I'm going to need 2 hydrogens for every 1 sulfite, so this will be H2SO3 would be my formula for sulfurous acid. So really important, balance charges. Make sure you balance charges and you look for that prefix hydro because that cues you into what type of an acid it is. So giving the name. Here we're given the formulas, we need to write the names. If I'm looking at this, the first thing I look, is it binary or is it a polyatomic acid? And this is not attached to a single element, so this is going to be a polyatomic acid, which means I do not use the prefix hydro. I just look at what the polyatomic anion is, and in this case it is carbonate, and 8 turns into ic. So this is carbonic acid. Do not use the prefix hydro. This one, the hydrogen is attached to an element, so this is a binary acid, which means I do use the prefix hydro. So hydro, and then I look at what the element is, and it's iodine, and we would change it to iodic because we want to give it that IC ending, and then we just add acid on the end. So hydroiodic acid. And the last one here is ClO2. If I look that up, because that's a polyatomic, I look it up under the anions list, and what I'm going to see is that is chlorite. Chlorite ends in ite, which becomes that OUS, so this is chlorous acid. I don't use the prefix hydro because it's a polyatomic. So that's how you do these. It does take a little bit of work to kind of figure out what type of acid you have. You do have some of these on your periodic table. If you look in the upper left corner over here on your periodic table, you're going to see some very common acids with their formulas and their names. So sometimes you get lucky and you don't even have to do this. You can just check out your list and it'll be there. But that's all we're going to do together. Make sure that you wrote down the rules and that you can identify the difference between binary and polyatomic acids.